Okay, thank you for joining me once more. This one will be a fairly quick one on fuel system components. And we've already been talking a little bit about the cross-feeding between two fuel tanks, depending on what engine you want to service. This illustration, you can see the left wing is got much more fuel than the right wing. So you're going to want to basically draw down from the left wing. And you can do that with your little shutoff valves, or you also have these cross-feed valves. These are somewhat used interchangeably, but there are a few questions that differentiate between the two. So let's take a look at them a little closer. Two selector valves are required on twin-engine aircraft, one for each engine. The right selector valve receives fuel from a main tank on either side of the aircraft and directs it to the right engine. The left selector tank also receives fuel from either main tank and directs it to the left engine. This allows the fuel to cross-feed from one side of the aircraft to the opposite engine if desired. And the question is, what is the primary purpose of the cross-feed system? Is it A, to allow the feeding of any engine from any tank? B, to allow the feeding of fuel from one tank for defueling? Or is it C, to provide automatic refueling of a tank to any desired level? Cross-feed system is the primary purpose is A, to allow the feeding of any engine from any tank. And here's where they're going to make a differentiation between the two valves. You can see above is the tank cross-feed valve, and below is a pump cross-feed valve. So they're going to refer to this figure and ask what is the purpose of the cross-feed valve. So you don't necessarily need the figure for that type of question. What is the purpose? A, is it to balance the fuel in the fuel tanks? Or is it B, to allow operations of engines from one tank? Or is it C, to allow the operation of the left engine when the right fuel boost pump is inoperative? Okay, the pump cross-feed valve is the one below. So that appears to be the one that would allow the fuel to flow from one side to the other. So I guess I'm leaning towards what, B? Sorry. Okay. Yeah, from one tank or either of two tanks. That's probably a better way of saying it. Here's what a cross-feed valve looks like on the instrument panel of a 737 with the cross-feed in the center, and they kind of show you where the fuel lines would go. The schematic kind of follows it. So if there's heat in this area here, or the low pressure, you can see where the low pressure signals are. There's low pressure here, here, and here, but apparently not here. With the cross-feed valve open, turning off the fuel pumps in one tank will cause more fuel to be drawn from the tanks on the other side. So that's a little trick is how they do it. They turn off the individual fuel pumps in order to balance the fuel load, I would imagine. Question. Normal fuel cross-feed system operation in multi-engine aircraft. A. Calls for the jettison of fuel overboard to correct lateral instability. No, that would be a little extreme. B. Uh, the system reduces contamination and or fire hazards during fueling or defueling operations. I'd have to think about that. I don't believe that that would automatically reduce those type of hazards. Uh, if anything, I could almost think of an argument why it might increase. Or C, provides a means to maintain a balanced fuel load condition. I like that answer the best. Fuel cross-feed systems allow a balanced fuel load. Sounds good to me. And what is meant by a cross-feed system in an aircraft fuel system? Um, it's a means where the pilots have some control over uh, drawing fuel from one tank or the other, depending on their present flight condition. A cross-feed system allows fuel from any tank to flow to any engine. All right, we've seen those type of questions before, so. Why do multi-engine airplanes have fuel cross-feed systems? Probably the same type of answer, so that any of the engines can draw fuel from any or all of the fuel tanks. To allow any engine to draw fuel from any tank. There are many fuel valves used in aircraft fuel systems. They're used to shut off fuel flow or to route the fuel to a desired location. Other than sump drain valves, light aircraft fuel systems may include only one valve, the selector valve. It incorporates the shutoff and selection features into a single valve, which you can see that in the illustration. You can select the left or the right, or you can actually shut off the fuel. Large aircraft fuel systems have numerous valves, most simply open and close, and are known by different names related to their location and function in the fuel system. And you're going to see these valves in other airframe systems also. Shut-off valves, transfer valves, cross-feed valves. Fuel valves can be manually operated, solenoid operated, or operated by an electric motor. The fuel selector valve for a multi-engine aircraft must have at least 3 positions. What are they? Well, we just saw that selector valve with the right, the left, and the off. It's a little tricky. I'm going to stick with that, right, left, or off. And cross-feed is the one that I wasn't sure about. So what's that, on, off, or cross-feed? All right. Unverified answer, okay. I think I found this as an editor's answer, but I've been not able to verify it. I can't show you one that has those 3 positions. So I would pretty much stick with, you may want to, I was hesitant to just throw out, there's some answers might suggest the word crossfeed, but I don't agree with it. Number 1, multi-engine aircraft isn't going to just have on or off. that's not what it is, unless it's specific just to uh, that fuel cell. All right. So the fuel selector positions for gravity feed single systems, you can see the tanks up at the top, and the fuel is by force of gravity flowing down to where it needs to be. They've got small reservoir tanks, and into the tank selector valve, which has three positions: off, left on, and right on. So that's basically it: left, right, or off. That's what we saw before. So gravity feed. Low wing single engine. Fuel flows from the tanks to a fuel selector valve. So you can see the tanks on the bottom here. So there's going to have to be some sort of fuel pump drawing it up to where it needs to be here at the top. It also looks like it's the same options. Left tank on, or in effect left, or right and off. And the low wing twin engine, what is that? So left, right, left auxiliary, and off. All right, I'm not going to worry about that. Here's a little close-up of a selector valve. Sorry. A feature of all aircraft fuel valves is a means for positively identifying the position of the valve at all times. And normally they'll use a detent, so it'll actually click into place or click up or down. That's a spring-loaded pin or similar protrusion locates when the valve is set in each position. Combined with labels and a directional handle, this makes it easy to identify by feel and by sight that the valve is in the desired position. Why must an aircraft fuel valve have a detent in its operating mechanism? To let the operator know that it has reached its maximum position in its operation. The detent gives the pilot a positive indication by feel when the selector valve is in the full on or full off position. A valve in transfer indicator light. Believe it or not, they got a few questions on these. Here's one over here. They're not illuminated. The valve in transit light, none of them are illuminated. It looks like there's two. Perhaps these two are two other ones. And when the valve is being opened or closed during that time period that it's actually running, the light will come on showing that the valve is in transit. It may be on just real momentarily. It's an important indicator to the crew. All right, be aware of what they are. I believe there is an oral question on them. Here it is. What's the purpose of an in-transit light associated with an electrically operated fuel tank shutoff valve? So why would you have the in-transit light? It basically alerts the operator with a light when the fuel tank shutoff valve is actually moving from open to closed or from closed to open. to provide an indication that the valve is in motion between one position and another. A different answer, basically the same answer. I'm not sure why I'm repeating it here. Video review. Looks like it'd be only a minute and a half, so we do the few supplemental questions I found. Fuel selector valves are usually of what type? Is it the cone, gate, poppet, or actuated? That's right, I have to flip around some of these slides. I wonder if I can just put you on pause. All right, I didn't really change much. So basically I'm showing this poppet type selector valve. Basically it's think of it as popping a little cover off its seat. And you can see the oblong cam is actually going around and opening up the different valves at the simultaneously. So that's how the inside of a typical selector valve is operated, which brings us to the question: fuel selector valves are usually of what type? And poppet would be the actual type. Now I didn't have any other slides. I had two more questions. The valve in a multi-engine fuel system that allows any engine to draw fuel from any tank is called a selector valve. Okay, I guess we haven't seen that. Oh, they're calling it a crossfeed valve, so let's see. All right, so I jumped on that one too quick. You can tell I haven't reviewed this in a while. So the valve in a multi-engine fuel tank or fuel system that allows any engine to draw fuel from any tank is the crossfeed valve. All right, I jumped on that mostly because we were mostly talking about selector valves. So I tricked myself. I have it in the wrong section. So be on your toes. And the device in a manually operated fuel selector valve that provides a positive means of identifying the valve being in a fully open or fully closed position is a detent A. I suppose a detent could be evolved into a spring-loaded lock, but the detent is the proper word. All right, that should do it. All right, thanks for being with me again, and we'll see you on the next one. Bye.